Basic derivative rules. In the previous video, we found the derivative of a function f by using the first principles. We used the first principles to obtain the first two differentiation rules, the constant rule and the power rule. If you haven't watched the previous video, watch and come back to continue learning more about derivatives. In this video, we will continue to find more differentiation rules, which make calculating the derivative of a function much simpler. Thanks in advance for watching this video. If you like this video, don't forget to like and subscribe to the channel and activate the bell. It is very important for the continuity of this channel. The constant multiple rule. If k is a constant and f of x is a differentiable function, then the derivative of k times f of x is k times the derivative of f of x. We prove this rule as follows. The constant multiple function is denoted by g of x. Let g of x equals to k times f of x. Now we use the definition of a derivative. We replace g of x with k times f of x and g of x plus h with k times f of x plus h. Now substitute them in the above equation. K is a common factor in the expression in the numerator of the function, and it can be taken out as a common factor from the terms. So factoring and using the definition of a derivative, we obtain the constant multiple rule. This rule says that the derivative of a constant times a function is the constant times the derivative of the function. Let's see how it works. Find each of the following derivatives. Always be on the lookout for constant factors before differentiating. To solve item A, factor out the constant from the differentiation using the constant multiple rule. We factor out the constant 6. We use the power rule to differentiate x cubed. We can simplify the expression by multiplying the constants 6 and 3. To solve item B, we factor out the constant minus 1. We use the power rule to differentiate x. We can simplify the expression by multiplying the constants minus 1 and 1. Item C, we need to differentiate the function with respect to r. Although it was convenient to establish the differentiation based on the use of the variables x and y, it must be pointed out that not all expressions are written in terms of x and y. Many of the formulae that we use are written in terms of variables other than y and x, and the rules are the same regardless of the variables involved. Pay attention. Sum difference rule. Let f and g be functions with the same domain and suppose that f and g are differentiable at x. Then the function f plus g and f minus g are differentiable at x and we provide only the proof of the sum rule here. The proof of the difference rule follows in a similar way. We prove this rule as follows. Let a of x equals to f of x plus g of x. Now we use the definition of a derivative. We now break up the fraction into two pieces and recall that the limit of a sum is the sum of the limits. Using this fact, we see that we end up with the definition of the derivative for each of the two functions. This rule says that the derivative of the sum of two differentiable functions equals the sum of their derivatives. Let's see how it works. Find the following derivative: the constant multiple rule, the sum rule, the difference rule, the constant rule can be combined with the power rule to differentiate any polynomial, as the following example. After applying the sum difference rule, we can differentiate term by term. Apply the constant multiple rule and constant rule. Apply the power rule and simplify. The product rule. If f of x and g of x are both differentiable at x, then let's prove this rule. Let a of x equals to f of x times g of x. Now we use the definition of derivative along with some algebraic manipulation. By adding and subtracting f of x times g of x plus h in the numerator, we have, after breaking apart this quotient and applying the sum law for limits, the derivative becomes. Rearranging the terms, we obtain. This rule says that the derivative of a product is the first factor times the derivative of the second factor plus the second factor times the derivative of the first factor. Let's see how it works. Differentiate the function. We use the product rule. Then we use the other rules. Multiply the first factor by the derivative of the second factor. Multiply the second factor by the derivative of the first factor. We apply the distributive law and we write the results in simplified form. The quotient rule. If f of x and g of x are both differentiable at x and g of x is different of 0, then we find a rule for differentiating the quotient of two differentiable functions f and g in much the same way that we found the product rule. We prove this rule as follows. Let a of x equals to f of x divided by g of x. We should notice that f is equal to a times g. We now use the product rule. At last, we divide both sides by g of x. This rule says the derivative of a quotient is the denominator times the derivative of the numerator, minus the numerator times the derivative of the denominator, all divided by the square of the denominator. Let's see how it works. We apply the quotient rule. Multiply the denominator by the derivative of the numerator minus the numerator times the derivative of the denominator divided by the square of the denominator. After factoring and simplifying, we get the result.